Welcome back. We already covered all the best practices for organizing and storing our data in microservices architecture. And we also discussed the best practices for splitting, managing, and operating each microservices by an independent team. Now, let's address the last part of the architecture, which is the front end. So, in this lecture, we will first discuss the problems of a monolithic front end. Then, we will learn about architecture pattern called Micro-frontends that solves those problems. After that, we'll illustrate how this pattern works with a real-life example. And finally, we'll discuss the benefits and the best practices for using this pattern. So, what is a monolithic front end? Let's imagine we have an online learning platform where users can search for enrolling and take online courses. The front end includes the home page, which displays a search bar where users can search for courses by keywords or by categories, and the course recommendations area that shows courses that the user may be interested in. Additionally, in the top right corner, we have the learner's profile button. When a user searches for a course based on a keyword or category, the list of relevant courses will be displayed on the page. And then when a user clicks on a particular course, it will bring them to the course landing page. When they decide to enroll in that course, they can click on the Enroll button, which brings them to the enrollment page. And on this enrollment page, they can provide their payment information, name, and billing address, and complete the enrollment. Also, if we go back to the home page, when user clicks on the profile button, they will be presented with their user profile and all the courses they are enrolling. We are not going to cover all the different parts of the platform, but you get the idea. Now, on the back-end side, we architected our system using microservices architecture, following all the best practices of microservice decomposition we already learned. We have a separate team of back-end developers that own each microservice. Each microservice keeps its data in its own database, and the microservices communicate with each other through a well-defined API that adheres to the company-wide standard. They also share a common set of tools and infrastructure to test, deploy, and monitor the system in production. However, on the front-end side, we have one front-end team that maintains a single code base responsible for all the user experiences we just mentioned, and the entire web application code resides in one single repository and is fed from the web application service to the user browser. Now, whenever the course discovery team wants to add a new feature that allows users to search for courses using additional attributes like course length, language, rating, or additional categories, we have a problem that team will have to implement it in their microservice first, but then also ask the front-end team to dedicate their time to adding that feature to the front-end. Similarly, when the course recommendation team wants to show the user more and different data, they will have to coordinate it and cooperate with that same front-end team to deliver it. This creates a dependency for all the microservice teams on that one front-end team, which becomes a bottleneck in development organization. On the other hand, when the front-end team, for example, wants to improve the user profile page, the front-end developers will have to learn and integrate with the user service team and optimize the enrollment and checkout process. The front-end developers will have to get very familiar with the enrollment and payment services, business domain, and APIs. So the front-end team has to constantly develop expertise in domains that belong to other teams. This tightly couples the back-end teams and the already constrained front-end team, which is what we wanted to avoid by moving to microservices. In addition to this organizational problem, this monolithic front-end code base has a more technical problem. As our business grows, so does the front-end. The single code base becomes very large to maintain and reasonable. It also takes a lot longer to test, and if we want to release a new UI feature, the entire front-end code needs to be rebuilt, retested, and redeployed. These are all the same problems we deal with already in a monolithic back-end application, but now we also have them in the front-end. To solve those problems, we can follow an architecture pattern called Micro-frontends. In this pattern, we split the monolithic web application into multiple front-end modules or libraries that act as independent single-page applications. The splitting can be done by business capability or domain, just like we did in microservices. In most cases, each page in the web application becomes a separate micro-frontend, but we can also have several micro-frontends visible on the same page. Each micro-frontend is completely decoupled from the other micro-frontends, should know how to load mount and unmount itself from the DOM in the browser. Each micro-frontend can also be loaded in the web browser or a standalone web application for testing purposes. More importantly, it is all by a separate team with full-stack technical capabilities and the domain knowledge to develop and maintain this micro-frontend. Although micro-frontends are then assembled together at runtime by a container web applications. When the user loads outside on their browser, the role of container application is to render common elements like page headers and footers, take care of common functionality such as authentication and shared libraries, and tell each micro-frontend when and where they need to be rendered on the page. Now, before we illustrate how it may work in a real-life scenario, I want to point out two things that are usually a big sort of confusion. The first thing is micro-frontends is an architecture pattern. It's not a web framework or library. Many web frameworks support this pattern, but we don't have to use any particular one to implement it. The second common source of confusion is between shared web components and micro-frontend. A micro-frontend is not a generic button, search bar, or some other UI element that can be reused in different places on the page. Instead, it's a single-page web application with very limited business functionalities. Different micro-frontends may reuse common UI elements, but the two concepts are unrelated. So now what we are understanding the idea behind this button. Let's illustrate this with the same online learning platform scenarios. When the user sends a request for the home page, the web application service sends back the container application to the user. That container application handles the user's authentication first. It then stores the authentication token on the user's device, so the user doesn't have to re-authenticate for every request or page reload. After the authentication is complete, the container application renders the header and the footer of our learning platform, and then it calls the entry points of the course discovery micro-frontend and the course recommendations micro-frontend. The code of each one of those micro-frontends will make a request to its relevant backend service to build the HTML with all the relevant data and then render itself on the page where the container application told it to. Similarly, when a user navigates to the user profile page, it will first trigger the unmounting of the course discovery and the course recommendations micro-frontends, and then re-rendering of the user profile micro-frontend, which is maintained by the user profile team, and it fetching data from its backend service. The same thing goes for course enrollment page, which gets its micro-frontend from the enrollment service and is maintained by the enrollment team. And every other part of our web applications follows the same pattern. So now that we understand the micro-frontends architecture pattern and get an intuition of how it works, let's talk about the benefit of pattern. The main benefit is that we replace the big, complex, and monolithic front-end code base with a few small and much more manageable code base, each for a different micro-frontend. Additionally, now each team fully owns its domain and technical stack end-to-end. So if a course recommendations team, enrollment team, or course discovery teams want to deliver a new feature, they can do it independently without waiting or depending on any other team. Also, each micro-frontend is much easier or faster to test in isolation since its scope is a lot smaller. Each micro-frontend has its own continuous integration, pilot, and deployment process, and the team owning it can release new features on its own schedule. Now let's talk about a few best practices for using the micro-frontends button. The first best practice is to ensure that the micro-frontends are loaded at runtime and are not expressed as compile or build time dependencies of the container application. Otherwise, all this is just separate the code base logically, but at runtime we would still have a monolithic frontend, require complete redeployment for every new feature. This best practice is very similar to the one we had on the backend, where splitting a monolithic application into modules or libraries did not provide the same benefits as splitting it into microservices. The next best practice is to ensure that micro-frontends don't share state and the browser in the browser. Sharing state would be equivalent of different microservices sharing a database, which we already know is a bad approach. So in different micro-frontends need to communication with each other. They can do it using one of the following ways. using custom events, callback, or using the browser address bar. In this lecture, we learn about the micro-frontends architecture burden. We first identify our system's technical and organizational bottleneck, which is the monolithic frontend. After that, we'll learn about the micro-frontends architecture burden, which splits the web application into independent single-page application, maintained and developed by separate teams. And all those micro-frontends are assembled by a container application at runtime on the user browser. We also cover some of its benefits and best practices that make this burden perfect for microservice architecture. Thank you, that's all.